the little formula, and it was the train number times 4 plus 2, and that would give you the perimeter.
Oh. Can anyone explain to me where each of those things come from? What does the T stand for? You said train number?
Yeah. Yes.
Okay, and why are you multiplying the train number times 4?
The part we didn't even figure it out, just works. It's kind of
It works. How did you first think of multiplying by 4?
I think like we were going like train number times 1, train number times 2, train number times 3, train number times 4, and like seeing which one works.
So were you looking at the table when you figured out that it was increasing by 4? Is that what you were looking at?
Yeah.
But you can't figure it out when you look at the blocks, what's happening? Why there's 4 on every one? Okay. Well, let's just start with the first train. Show me the first train and show me the perimeter. Go ahead.
The first train is 6.
6, perimeter of 6. Okay, now take the 1 and 2 trains. What's the perimeter?
10.
10.
So how much did it go up from the first one? 4. Okay, now how about the third one? Look at your third train. What's the perimeter?
14.
Which one is it? Add it up again. What is it coming up? The third train. What's the perimeter? 14? You have 14? Okay, so it went up
4.
Okay, here's what I want to know. Why is it going up 4 every time? Why is it going up 4 every time, Cameron?
I think I know why.
Okay, talk real loud.
You would think it would go up by 6 since the first one is 6, but like on the second one, it's not 12, it's 10. It's so because these two sides are not part of the perimeter anymore because they're not on the outside, they're part of the inside of the shape. That's why it's going up 4 instead of 6.
Which 4? Show me the 4 that is going up every time. Where's the 4 that's adding to it? Just look at the train of 3. Look at the train of 3. Now tell me where, if you add one, where's it getting the 4 more? Where's it getting the 4 more each time?
Yeah, like on the sides of everything. Because like if you take it apart, then this is 1, 2, and then 3, 4.
Okay, so you're saying it's taking 2 off every time there?
Because this is one side and this is the other side.
So when you said T times 4, why are you multiplying by 4 each time?
Because it increases 4 every time.
Every hexagon is adding how many to the perimeter?
4.
4. But then what about that plus 2? Where's that plus? Why do you have plus 2 on the end of your formula?
Because of the 2. Because of the 2 sides right here.
You think it's the 2 sides that are touching or telling you to add 2?
Yeah.
Think so?
And because maybe it sort of completes it, for train 1 it's 6, but 1 times 4 is 4, then you add 2 and it's 6. Same for train 2. It's sort of like if you just multiplied it by 4, it went the other way, and if you add 2, it's the perimeter.
Okay. Everybody take a train of 4 in front of you. Take a train of 4. Now, I want you to look at that first hexagon. How many sides is it contributing to the perimeter?
5.
5.
Is it 5 on that end one? Okay, how about the second one? How many is it contributing?
4.
4.
What about the third one?
4.
4.
What about the last one?
5.
Why are they different? Why was the first one and the last one different than the ones in the middle?
Because the ones in the middle, because the ones in the middle, they are 2 sides are attached, and the ones on the outside, only one side is attached to another block.
Only one side is attached, so what's that out here?
This is
An extra N, an extra N. So what do you think about your formula?
that's why you're adding 2, because the 2 on the end.
Are you getting that? Okay, would you work with the rest of the group and make sure everybody can tell me exactly where each one of those things come from? Explain to them what you just realized, okay, about the 2 on the ends there. And then see if you can figure out what the perimeter of the 100th train would be, okay? Okay, so you guys do that? Good work. Nice work. Okay, what have you guys been able to come up with on this? First of all, did you agree on your perimeters?
Yeah.
Did you figure that out? Did you have any trouble coming up with the perimeter?
Not really.
No. Okay, so you got the first 4 perimeters and you all agreed on that. And then were you able to come up with the perimeter of the 10th train without actually counting them?
We're still, yeah, we kind of come up with it.
Okay, well explain what you did. Explain how you worked. Riley, why don't you start?
Well, I actually created a formula.
Talk real loud, Riley.
I did the train number minus 2 from the outside because it was minus 2 from the outside
You're taking off the end hexagons.
Yeah.
Why are you taking those off?
because I noticed that these would just equal 4 on each hexagon, but this outside would equal 5.
Oh, so you're taking those off because they're different than the others. Did all of you understand that? Did you agree?
And then I did
So you
after-
took your train number 10.
minus 2.
Minus 2.
And that was in parentheses. And then I did that times 4. And
Because each of
because
these.
each of these equals 4
Okay.
in the
Okay.
middle. And
Right.
so, and then for the 5 on the outsides, I did plus 5, and I did plus 5 again.
Plus 5 plus 5.
I think we all understood Riley's way,
Uh-huh.
but we were kind of confused on Colin's way.
Colin had a way too? You thought of
Yeah.
another way? Okay, let me ask you one more question about this. On the plus 5, is there a shorter way to say that?
You could do just plus 10.
Plus 10, that would work too, wouldn't it? Be the same thing, but this kind of shows you exactly where you're getting it from, 5 from either end. Okay, Colin, talk about your way. What were
I
you
actually
thinking?
had 2 ideas. Well, it was to take, if you had 2, I know there's going to be 5 showing.
Okay.
So I counted it as 4, so it was 4 times 2 equals 8 minus 2. Well, it's plus 2, plus 2.
2, okay.
And I got, well, I'm getting kind of some mixed answers because I've got a couple one that were the same, but some that were not. Because I'm not counting the sides and then adding them back on the end.
Would it only work with even maybe?
Yeah, actually, I think that.
Well, I see on your paper you had written, you were counting how many times that you were subtracting, weren't you?
Right here.
Yes.
Yes, because I did that because we're trying to find something that works with the joints to block off the joints of these 2.
Okay.
But we're kind of stuck there because we don't know how we could figure out how many centimeters of the perimeter there are. We can't really figure that out.
Okay, well let's do this. Let's take a train of 2. Take a train of 2. How many hexagons?
2
Two.
hexagons.
How many joins?
1,
Okay, add a train. Add a hexagon. How long's your train now?
30.
hexagons.
How many joins?
Minus 2.
There's always 1 joint less than there is.
train number minus 1.
Train number minus 1 would be the number of joins. And for every join, you're subtracting how many sides? 2. Do you think that you could work with that and get that written down now? Like your
Because-
train number? And then you have to do what to find out how many joins?
Minus 1.
And
Minus 1.
I
And
kind
then,
of thought about that, and I was kind of stuck on train 1. How would that work? And I just thought about it. There's no joints, so there's 0 joints, so that works there.
that's awesome, Colin. Keep working with that. That's right. It does work for 1 hexagon. I want you guys, I love that formula you figured out with the 5 on either end. That's perfect. I want you to be ready to share that with the group. The next thing I want you guys to do is help Colin get that written down where you're counting the number of joints and that you're subtracting 2 for every joint, and see if you can get that written up into a formula, and see if you can find out the perimeter of the 100th train too. And you guys work on that, and I'll be back. Okay? Okay, great. That's awesome. And y'all scoot in just a little bit. Okay. Okay, what'd you guys come up with on yours?
I came up with a formula. It was T, which stands for.
Talk real loud, Logan.
I came up with a formula. It was T, which equals the number of tiles
Okay.
times 2 plus 2.
Times 2 times 2 plus 2. Okay. Do you know what I'm going to ask? Where'd you get y times 2, y times 2, y plus 2? And if you can show me that, I'll believe your formula works.
Because the hexagon, the sides when there's
Can you
one-
show me with the blocks? I can understand better.
Okay. When the hexagon, the top has 2. So 1 would be 1 times 2
Okay.
times 2
Oh, so you did times 2 for the top and then
times 2 for the bottom.
times 2 for the bottom. Did you understand that, Jonathan? You did? How about you, Jasmine? Okay, and then what?
And then you would add the sides, which is where I got the plus 2.
You plus 2. What about on a train of 3? What happens?
3 times 2, 2, 4, 6 times 2, 12 plus 2.
So you're only adding an n for the very outside edges? Okay. Caitlin, did that make sense to you?
Not really at first, but then I kind of got it.
Okay. How were you thinking?
Well, I was thinking that you would just make these one and then after he got done like explaining and everything, then I came up with my own formula.
Okay. What'd you write down?
And I did P times 2 plus 2. That means the perimeter, and then 2 would be the 2 sides, and then I tried it on 2 tiles.
Show me how that's working. Tell me what you're putting in for the... You're saying
2, and then that would be 4. So, let's see, 4 times
real loud, Caitlin.
2 equals,
Where'd you get the 4?
well, I got the 4 from the perimeter right here.
So you're saying every hexagon has 4?
Well, not everyone, but like every time that I like add a block,
You're adding 4 more?
well, 2 more, like, yeah, 4 more if you count.
Top and bottom. You're putting the top and the bottom together to get
Yeah.
your 4. And so you're saying the hexagon number, not the perimeter number, but the hexagon number times 4.
Times, well, like whenever I do 2, the top it equals 4, and then the bottom equals 4 too, but I multiply that times 2.
Oh, I see. So
8, and then plus 2 equals
what's the
10.
plus 2 for?
Plus 2 is for the sides.
Okay, show me with 3. Show me how it works with 3.
3,
What number do you start with?
6, because 1, 2, 3, 4, 5, 6.
How do you know to start with 6? So what if you were trying to figure out the 100th one and you didn't know how many was going to be across the top? How are you getting that number?
You would, well, I was trying to think of as many as I could, and then once I was trying to figure out 100, I was thinking that you could do, since you have to add the sides too, then it would be like 40 something or something, because
Jasmine, you look like you were about to add on to what she was saying. What were you thinking?
You were saying, like, how would you know to start with 6? If you were doing, like, 100, what would you start with? I noticed that there's 3 blocks, okay? And there's 6 on top and 6 on bottom. 3 times 2 is 6. And if you chunk that with 2, it'd be 2 times 2 is 4. Okay, so that seems to work with most of them. So if you did 100 times 2, that'd be 200.
So there's going to be 200 across the top and then
200 across the bottom.
200 across the bottom and then
Plus the sides be 400.
I think you guys are onto something. Can you try to get that written down in a form?